Hello, my name is Heather Leeson. I'm with Open Knowledge Foundation, specifically with the School of Data, and I'm super excited today to have Codrina today. She's going to share us a little bit more about mapping and some of the skills she's learned with OpenGeo, and she's taking her PhD right now in geospatial, so that's pretty nerdy. Hooray! So we're going to learn a little bit about some basics of mapping, some types of tools, and we definitely want to answer your questions. So if you do have questions, please don't hesitate to ask, either on the Google Hangout or in this window if you can join. So Codrina, over to you. Where are you based today?
Hi everyone. Heather, thank you for the very generous introduction and for sharing that I am struggling with a PhD. Yeah. And thanks everyone for joining, and I hope that you will learn something interesting today, and I am open for your questions. So shall we go? I'm losing you. Can you hear me? Yes, well, I cannot hear you. This is interesting.
I went on mute so that I wasn't heavy breathing.
Okay.
All good. Please go ahead.
Okay, so
and welcome my fellow School of Data friends and fellows.
Yeah, hi. Okay, so I am going to share my first 4 slides because they're important in my perspective. Let's see. I hope that you can see them. Okay, can you see them? Okay, so what we're going to do, what we're going to talk about, I wrote a very small summary. Well, we're going to talk about mapping, of course, on that, and then I'm going to discuss a little bit about what kind of data can someone map, and then we are going to analyze that certain data, look at it. Then I'm going to discuss a little bit about the tools to make beautiful maps, of course, and here I'm going to talk only about open source and free instruments, and then at the end I have a slide with some resources from where you can take the data. Okay, so let's start. Well, what is mapping all about? Well, first maps kind of looked like this. So our interaction with them kind of looked like this at the beginning. So what's happening today is that maps are a little bit more different than they used to be, and our interaction with them, it seems that has changed too, right? So what is this all about? You know, we've all seen maps, and we've all played with maps, and we did maps at some point. So what is with this change? Why do we actually do maps? Well, it gives us a sense of where we are. You know, it gives us a sense of understanding the world around us. So this is what was happening at the start, and this is what's happening now. We're practically all map makers, because, you know, when you think about going from point A to point B, you know, you're actually making a map in your mind. So practically, if everything can be mapped, and if we have so many tools in this technological era, and should we all be doing maps all the time? So not really. Well, first question that everybody, first question that anyone should ask is a map the best way to visualize my data? Is it really helping me transmit my message? Is it important to do it? Because I have the data, I can map it. Of course, if I have some kind of a location-related information, like the name of the country, like absolute location, longitude, latitude, like if I have this. Okay. I will stop from now to now, because I want to see if anyone has one question. So my eyes will roll over for some point. Okay. I just saw that people are writing, and that's why I stopped.
Yeah, no, what I did is I put the slides, we put them onto Google Docs. That way you can share them this way as well, so you have a couple of ways. That's the only writing we did, but thank you.
Okay, well, so we were talking about the fact that a lot of information that we are using and that we are seeing can be mapped, because most information is related to a certain space and to a certain location. At this point, I want to make a reference. Not only absolute location can be mapped. For example, an absolute location is something that you give through longitude and latitude. No, one point will always have one pair of coordinates. That is an absolute location. But we can actually map information that has a relative location. For example, where am I related to my computer or related to a person? And we can think about that, and we can map that information too. So the first thing when you have a data set, you look at it and you're thinking, is this important to put on a map? Do I bring a new message with it? Because yes, I can map it. Yes, I know how to do it. So what is all of this about? Well, as a very important point, maps are really useful when significant information is added to your message by making spatial correlation and analysis. For example, I have a set of information with roads, I have a set of data with buildings, and I have a set of information with crime rates. If I put those all together on a map, then I will find out where I will be living, where I will be renting an apartment in a safe neighborhood. I could get that information if I would do a tabular analysis on the data, but it's not as fast, it's not as intuitive, and for sure it's not as prettiest. So with that perspective, I can see that making spatial correlation brought an added value to my message. So this is why I did it. Okay, so now we talked about what kind of data is mappable and what is the question that we are supposed to be talking about, that we are supposed to be thinking about when first starting in analyzing our data. Now, I think that we should take a closer look to what actual data is. It's important to say, and it's important for us to realize that data by itself, it's neutral. Data is neutral. Data is a text, it's a number, or it's a symbol that we associate to a phenomena, to an individual, to an instance, to a process. So by itself, data is neutral. It doesn't say anything. But then comes the interpretation of the specialist that has a certain expertise in what he's actually presenting. So the meaning of the data set is given by the interpreter. So this is one variable, this is one parameter. If you're using a map to present your information, then another very important parameter comes in. A map is, mathematically speaking, a distortion of the real world, because you cannot make a round ball into something flat, without any kind of deformations. So this is another distortion of the reality of the world that we have. This is mathematically calculated. We know all the errors, but they're there. And as not everybody in this world is a cartographic, we have to keep this in mind. Then that no matter what map we are looking at, it has a natural, so to speak, distortion of the world, of what we are seeing. So this is the second variable that we are introducing into it, the way that the map by itself, through its own definition, already distorts reality. And then we have the third parameter, which is the way that the specialist chooses to show the message. The way that the specialist chooses, some kind of information is going to show, some kind of information is not going to show. And that, again, it is a decision that the person makes, that the specialist makes. So when we're thinking about maps, we're thinking that there are three variables to consider. And the fourth variable, which is very important, is to actually understand the context in which that map was built. For example, if we read now a map that was built in, I don't know, in 15,000, like the map that was on the first slide, we might not really quite understand what it says, because we do not understand, probably, we're not all historians, and we do not understand the context. For example, if you look now at a map, and at a historical map, a very old map, and you see a syntagma, something like here be dragons, then you're thinking you're looking at a cartoon and not a scientific work of art. So it is really important when we try to understand a map, to actually think about the context and everything that comes behind that map, so to speak. Two steps that are important when you build your map and that everybody should do is, first, you put all your information on the map, everything you have. The second one, you start taking off and removing from the map all information that you consider not significant for the message you're trying to transmit. You do that when you do your map. Everybody else does that when they do their map. So you have to understand that even if it's a scientific product, it's a mathematical calculated product, it can foster some kind of subjective interpretation, so to speak. And another very important aspect, when you set off in visualizing your data using the map, you have to be very sure that you have perfectly understood what you're trying to map and the message that you're trying to transmit. So I think that the bottom of line here is understand your data that you want to map, like, perfectly.
Codrina, which slide are you on, just to ask?
I am on the slide looking at the data. I think it's number 7, and I
slide
have, like,
number 7. Cool.
Yeah, I'm sorry. Okay, I think I have
Yeah, I know that we were having some issues with Google earlier, so whatever makes you comfortable. I'm certainly learning lots. I just wanted to kind of let you know that I just want to know which slide you're on. So we actually have the link, and I've shared it with people so they know where to find the slides.
That's perfect. That's perfect. Okay,
cool.
So, okay, so we were talking about the data and how it is neutral, and okay. And this is a slide that I prepared because I think it's really, really visualized, and it has a real impact. And now I'm talking about the slide 8, where we have 2 maps, well, actually 2 representations. They're not really maps, they don't have a legend and so on. And these are both mathematically correct. They are both, I hope that everybody's looking, so I don't have to share my screen. Should I share my screen? I don't know. Should I share my screen? Okay. Yes. Okay, I will share my screen if I will be allowed. Okay, so this is, okay, share my screen, share. Okay. Okay, so this is a slide that I prepared because I wanted to have a visual impact of what mathematically correct means, but the fact that we have to keep in mind the distortion there is, even if it's very well calculated and it's scientific. For example, here we have 2 representations. They're both mathematically correct. That means that they have this mathematical calculations of how to represent the world. But we can see that Africa on the left side has one kind of dimension, but on the right side it actually shows that the distortion on the first map is quite significant. So this is just...
It's the Mercator problem.
Exactly, but you know, this is very interesting because it's not really a problem. It's just all projections present distortions. It's normal. But the fact that, for example, in my mind now, if I think about the size of Africa, even if, I don't know, if I know, scientifically speaking, I know that Africa is big, so to say, somehow subjectively, because this is the map I've been exposed since I was 3, 4, 5 years, and this is the map I saw the first time, somehow it's really difficult for me to understand it. And I'm a cartographer, so I can only imagine what this means for people that don't do this every day. You know, we all have our own hobbies and jobs and so on. So I can understand that this is really important, and this is what I'm trying to stress out here, that this is, even if it's scientifically correct, we have to understand that it presents some kind of distortion. And you will always see that on a map, no matter the map. Kind of like statistics, probably. Okay, so this was the slide. Let's see here. Stop. And then for my next slide, we are looking a little bit even deeper in the data. And I'm going to talk a little bit about the types of data and the forms of maps, what kind of maps can create. And here we are at slide 9. Okay, and well, data can be divided in a lot of ways, but cartographically speaking, we can think about 3 main categories. First of all, you can have a set of data that is sequential. That means that the information is actually ascending or descending. It's like 1, 2, 3, 4, 5, and so on. And the way that you represent that information, the colors that you use, the symbol sizes that you use, should portray the fact that your data is sequential, from small to big, from big to small. Another kind of data set that we can have, is divergent. And the best example I have here is temperature data. For example, you have a middle value, which is 0. And then you have a maximum minus, for example, and a maximum plus. The way you represent that information on a map should portray the fact that the data inside is divergent. For example, you use a very light color for the medium. You use a white, for example, for the medium, and then you go hues to blue and hues to red, or something like that. And when you look at the map, you understand that you have a middle very small and very big. And the other kind of information that you can have, another kind of set of data, is qualitative, which is, I don't know, white, black, blue, numbers, not numbers, names, and so on. So when you receive a tabular information or something like that, the first thing that you're thinking is, what is it representing? Like, does it represent the number of people? Does it represent temperature? Does it represent crime rates? And the answer to that question gives you the kind of information, the kind of data that you have, and how you should go about representing it. This is the first. And the types of maps, maps like, they can be categorized in a lot of ways, but I actually chose this kind of division regarding the way that you show your data. And you have, I think I mentioned that I'm at slide 9, so everyone can join me. And for explanation about what each map is, I have the notes in the slide. I think everybody can see that, right?
I saw that. Those are excellent notes. I always enjoy that, because that way people afterwards, if they're listening to the video, right, or if they only have a chance to look at the slides, they can look at the notes and get a good context. So thank you so much.
But you're welcome. So the isopleth, you have the dot map. The first one, the chloropleth one, it's that map which has a lot of colors. You have like polygons with colors that represent the data behind. This kind of map is suitable and very highly recommended by cartographers to be used with only with data sets that are somehow normalized. For example, density is a variable that is normalized. You have the number of people on a certain surface. So this is this is a kind of data set that you would symbolize through a chloropleth map. This kind of map is not at all suitable for raw data, because this goes because the way that you divide your information could show 2 different colors, but when the difference is of 1 person, for example, the way that you divide your classes, you have in one class you have 5 people, and the next one you have 6. The difference is really small. It's but the visual impact is really big, and you are misled that the difference in the number of people is actually big. So these maps are good for a smooth process, like something that goes smoothly on the entire domain that you're representing. The isopleth one is the kind of data that the kind of map that you would have like with all kinds of isolines. You know, an isoline is something, a line that unites points with the same value, even if we're talking about altitude, about pressure, about bathymetry, or something like that. So the line represents a value, and what is on the right is bigger, what is on the left is smaller. This is very good, for example, for relief maps, for contour maps, you know, because it is a continuous phenomena or a continuous description of the environment. Okay, the proportional symbols. You probably have in mind all kinds of maps that regard, you have these circles, all kinds of sizes that represent some information on the map. You know, you have the contour of countries, and you have these circles that have different sizes and different colors. Well, these kind of maps are very good to represent sets of data that show sequential information, like the first description. Now, if there is any question by this time, or if I should be speaking a little slower, probably, Heather, I'm counting on you to stop me when I start to mumble around. There are a lot of
actually,
in my head, and
no, I'm just trying to absorb all this intellect. It's super interesting. And also, I wanted to say that you are speaking at the right pace, and I actually don't have any questions. Does anybody else have questions for her at this time?
I think I do, yeah. I mean, I can also keep the question for the end. This is Milana from School of Data. I think one of the most important things that you mentioned, and that, like, if you could spend like 1 more minute talking about it, is normalization of data. When looking at maps, this data can be deceiving because people just take, for example, the GDP of a country and put it on a map, but they don't do GDP per capita. That would be a normalized data, and that would actually, it's not just the wealth of the country, but the wealth of each individual in the country. So if you could spend a bit more time to talk about why normalizing data is important and how we do that, that would be amazing.
Sure. Well, the normalizing data. I'm trying to think of a synonym that could be of a bigger impact than normalizing. The idea is presenting a ratio. For example, if you are thinking, let me think of an example. Well, the first thing, we normalize information. We normalize sets of data because we need to understand a parameter related to another one. For example, let's take density, because we all know what that is. Population density, for example. You want to know how many individuals you have on a certain, compare population. You need to compare these to another place on your map. So if you, for example, if you would use this for, I don't know, proportional symbols, you would want to show how many animals you have in your country. For example, how many cows there are. On a county that is smaller, you know, if you have a small symbol showing that you have only 3 cows, and on a county that is bigger and you have the same symbol showing 3 cows, then the visual impact that the reader gets is not that in the 2 counties the number of cows is the same. And I'm going to talk a little bit later about hierarchy on the map and how we are presenting that and what does it mean. Normalizing information and making a ratio actually helps the reader of the map better understand the reality, because the human eye, when you look at a picture or a map, the human eye it's difficult for the human eye to make a very clear difference and distinction between color, between combinations of color, between combinations of color and form and size. And I'm going to show that again a little bit later. So I'm not sure if I was very, very clear on that, but if you put, for example, just imagine this. You put the same size, the two circles of a same size, of different colors, for example, on another shape which is of different sizes, then the two squares will not at first seem at the same size. And now imagine you're looking at a map that has 200 squares or 200 circles. So I'll just try, for example, to draw something here to make it my idea, to make it clearer. So this is, okay. So here, you see, these squares are actually the same size, but when you look at them with when you look at them in comparison to the bigger shape that goes around them, then your understanding of the map can be deceiving. So now you have only two representation. You imagine you're looking at the map of, I don't know, United States, where you have a lot of states, and you have all kinds of I don't know, all kinds of circles that are trying to represent numbers. So this is the difference. Does that answer your question, Milana?
I think it more than answers my question. Thank you very much, Codrina.
Thank you again.
You're welcome. Okay, so where were we? I think we were talking about the types of maps, and now we were talking about dot maps. So with dot maps, we actually represent density. For example, density. That is a good thing, because dots represent density, period. If you have more dots in a place, then you are thinking intrinsically in your mind that you have a bigger density of something. But again, here it is important to make a difference between the fact if those of a dot represents a normalization of something. For example, one dot means 100 individuals of a species, or if one dot represents one individual of species. So this is just a thought. And I see here that on my slide number 9, I have I have like this thing written here, which is metadata. Because we discussed about the map and the way that it is and how we should represent it, and so on. I think it is really important to discuss about data. So metadata is information that you add to your set of data, or somebody who builds it or who has it adds it to. Metadata is why? Because it essential information about the data set you're looking at. For example, it gives you reference of the person who did it. It gives you reference of the purpose that brought that data set to life. And that is important, because if you're trying to use a data set for another purpose than the intended one, you should know it, because there might be problems in representing, and the reality that the data set could be distorting. And that doesn't mean that the data is wrong. That just means you're using it wrong. And this is something that you should consider. So basically what I'm trying to just say is that just document everything that you do, including the data sets that you create. And so that's what I wanted to say there.
One thing that I would add, Codrina, is that I said this on a Skillshare earlier this week, that what does the data not show you is also equally important. So when at Ushahidi, that was really interesting for me, because when you have densities of dots on maps, people assume that's where, you know, there's more reports of corruption, but there could be all kinds of variables, like there's no mobile service elsewhere, that's where their outreach network was. Like, there's all kinds of variables in it. So always having data notes, like you said, is super important, so that people can understand the context of the decisions you made around showing the data and sharing it, especially in a map context. Because maps, much like humans, can lie, especially if you use distorted data, like you said.
Exactly, that's true. And maps can lie, actually, there is a very, very nice book that
I know.
that is
It's like we're tag teaming or something, you know, Map Love. Let's give people a reading list. Go ahead, please.
Yeah, but that is a great book. Anyway, I'll just share a link at some point. So let's see. Okay, well, we discussed about the metadata, and let's go on with my next slide. The next slide that I have, which is number 10, actually talks about the way that you represent the data that you have. And on this slide here, you have 3 projections actually, and you have the same. I'm sorry. One moment. I have one small problem.
Can I help?
I think my internet is not doing well.
No, we hear you. You're fine. Oh, I think we lost her. Look at that, the freeze frame that is the freeze frame. All right, so it looks like we lost Codrina just briefly. So I've shared a link from a blog post from by Patrick Meyer about Lying with Maps from 2009. I'll find that book, but does anybody else have any recommendations around dots and maps while she's joining us? Or any other examples of map experiences you've had in the context of what she was talking about? That would help us. Nobody. So I think the power of maps is a good one. Okay, thanks, Jamina. Okay, I'm going to look for these links. So does anybody else have any other books? I've read The Story of Maps is really interesting. Codrina was talking earlier about There Be Dragons and maps that have that on there. And actually in the 17th century, they used to have this technique of putting animals, and this is where you get the animals related to the countries in maps. So there used to be maps literally that were drawn with animal depictions based on geopolitical military situations. So for example, that's where Russia had a bear on it. So all these weirdo examples of like how adding visual images on top of a map construes some kind of political agenda, and that's super interesting to think about. But I think we have you back, Codrina.
Yes.
How are we doing? That's okay. We were just talking about books. Don't worry.
Well, I have a little bit of treat for you at the end of the
Oh, you're giving us free map books? Hooray!
No. I wish, but I am. Whoa, a treat! Of course, a treat. I'm actually going to give you some videos. I'm going to share some links with videos. They're super, super, super cool, and a song.
Okay, please go ahead.
So, okay, we were talking about slide 10, and I was saying how we have 3 projections here, and we have the same data set that is mapped on all the 3 projections. And what I tried to show with this is actually how the base map, the distortion, the projection that you use, and the distortion that that projection has can influence your map reader. So what we have here, we can see that the number of classes are the same, the division method is the same data set, everything is the same, only the projection is different. But now look a little bit. Unless you represent the information with the proportional symbols, it is very unlikely for a non-cartographic, so to say, reader, or not a very skeptical reader of your map, to see that difference between United States and Europe is actually quite very small. You see, in the first map, I consider to be the one on the left, you know, it's really difficult to understand that, and that comes with the fact that even if the colors present the reality, the shapes, the form, and the size of the shape actually influences the reader, and you can be very easily misled. For example, you're not thinking that Europe is close to USA. You're not doing that at all. And that goes for the second one. It's only at the third kind of map that you see that clustering of information, and it makes you think, oh, yeah, that's close to USA. Yeah, that's true. So this was just an example to show how the same data that you map can actually not necessarily be misleading, but misinterpreted. Okay, so let's go and a little bit further. And for my slide 11, what I prepared is visual hierarchy, a very important thing when we choose the colors that we want to use for our map. And I think I'm going to share with you something that I use with a high success, I could say. Here, I'm going to share with you the color brewer. Okay, and I'm going to go back to that immediately in just a few seconds. Now here, if everybody is looking, or I'm just going to share it to be absolutely sure that we are all looking at the same thing, because I think it's important. So here we have a slide presenting visual hierarchy. The impression of actually being on top, or being more important, you know, it gives a more qualitative aspect than a quantitative one, is given by this visual contrast. For example, a darker hue of something will give you the impression that you have higher density, for example, there, or that it is more important or much bigger. So I don't know if I succeeded in sharing my screen. But you can see here that, for example, you have a plane. It is a 2D. It's a bidimensional space here that we're looking at. You know, you see those squares, and nothing really tells you that the smallest one is on top. But I want to hear the first person who says that it's not there to explain to me. So this is regarding the visual hierarchy. So when you have information, you have a data set, and you want to transmit a message and information, you have to take into account the visual hierarchy that you are using in your map. I think this, actually, I know that this applies in infograms as well. So, okay. So let's go on and let's see what I have prepared for my next slide, which is number 12. So we have discussed about data. We have discussed about data that we can map and how we should look at it and how we should understand it. And we discussed about how we should represent it, and what kind of maps are there, and if they're good for us or not. And now at the end, somehow we should discuss about actually checking the data that we mapped. When you have a draft map, for example, you should think about some aspects, you know, like some general aspects. So you should think about the geographical elements. For example, if you have all the borders on top of the map, if they are visible, you should think about the names of the places, if you have them correctly written, or if it is important even for those names to be on your map, or if it just clusters more and you should take them out. So you should think about the geographical elements which are really important. You know, you could consider this like a base element. Then you should think about if the things that you added on your map are correctly positioned. For example, if you draw some shape on top of a country trying to represent something, or you wanted to put a photo and you did that manually, you have to check to see if that is where it is. And this is even more important when you have data that you geocoded yourself. Geocoding means to assign latitude and longitude, you know, like a pair of coordinates to a certain element that is identified for a location by a name. For example, if you have a street name, that is a location information, but we say that you geocode it when linked to that street name or to that or to that postcode. You actually put a latitude and longitude. So this is the perception. Okay, thank you. So then again, we're thinking if everything is correct, then we should look about at topology. Well, I think here a little bit of explaining is in order, and please stop me if there are any questions at some point. Okay, so now we're talking about the topology of the data that we have. The most important thing about a map in the old days, when maps were only on paper, and the most important thing of geographical information systems nowadays, which we call GIS, is the fact that you have geometry connected to information, to an attribute. For example, related to one point. You have a one point in 2D, and it is given by latitude, longitude, x and y, and so on. You can have tons of information, the name of a town, the number of population, and name it whatever. This is the power of GIS. The fact that they can put it together, they can put it on a map, they can overlay different kinds of layers to get additional information, additional messages, and the fact that you can analyze all that information in a spatial context. You can make a correlation given by a geographical position, by an actual place on Earth. So if you want to do that, then you have to be absolutely sure that the geometries that you use are correct, because, as my GIS teacher used to say, for example, he said that GIS is just GIS, and there is a very clear there is a very clear principle that it goes by, and it is go G, which is GGO, sorry, which means garbage in, garbage out. If you don't know what you're putting in, then what's going out, it's not good. So going back to topology is that you have to make sure that your geometry is correct. Topology tells you if, for example, you have any overlaps in your polygons. Speaking from the point of view of reality, boundaries of two countries can never overlap, and boundaries of two countries cannot have any spaces between them. So this is a reality that has to transmit into your GIS, for example. When you have data, when you actually create data by digitizing, for example, this is not always something that you can be careful at, and you can make mistakes because we're all humans. Happily enough, there are sufficient instruments to check topology and to check errors of topology to see if everything is as it should be, if you don't have any kind of silver polygons, which means that there are very, very small polygons that you cannot see with your bare eye. For example, for a country, you have polygons that in real world would have about a meter, 1 meter square. And this is important because geometry is important in the analysis that you do. A computer understands the reality by 0 and 1, and if the geometry is not correct, then it doesn't matter that you cannot see the error with your bare eye, because the computer can see it right away. So check if you don't have any kind of duplicates on your data, if you don't have overlaps, and so on and so forth. Again, the topology is given by the data set, what it represents, what is the reality and what is the phenomenon that it represents. Okay, another question that you should ask yourself at the end of a map is that if you removed all the unnecessary information. A map is really important, and it's always a compromise between what you get out of it and what you leave. You should, when you start making your map, don't worry about the software you're going to use. Think a little bit about the colors you're going to use, but be very, very careful what information you put in, and be very careful. Don't make it too clustered, because the message won't go out, even if it's pretty. Don't make it too clusters, too big, too much. Then what about the cartographic elements? We've talked about projections, and we have seen how important the projection is in actually transmitting the information and leading the reader of our map in one direction or another. We're thinking here about the colors of the map. Usually, cartographically speaking, it is not recommended to have on a map more than 7 colors, because the distinction between what you're trying to show becomes really difficult to do it.
One thing that I used to say to people who are creating maps at Ushahidi is also to think about how people chunk and manage information. So not just visually, but information-wise. So if your map's trying to make 7 points, that's enough, right? Like whatever conclusions you are, like don't try and overwhelm people with the detail, because then it just delays the quality of your map. So much like colors can confuse people. If you have 40 colors, that's really nasty. And maybe you might want to kind of like do gradiated colors or something else. But I would bucket the data into different categories. And when it comes to how people manage information, there's something called chunking. So when you're thinking about when you're teaching people, it's 7 to 10 points. That's a maximum. And in terms of instructions, 7 to 10 points. And normally I like to go underneath 7. Because I think that you're trying to focus things. And so I think the same kind of principles for teaching and learning and how people digest information applies to how you do a quality map.
Yeah, absolutely. Absolutely. It's really important.
Are there any questions? We have about 10 minutes left for folks, just in case. Anyway, back to you, Codrina, if there's no questions.
Okay.
I'm learning tons. I know everyone else is really riveted too, so rest assured. Plus there's treats, like promising us treats and a Google Hangout, hooray!
Okay. Well, another thing that we should think about when you make a map, which is a final product, is data attribution. It's really important to license the information. It doesn't matter if it's free for everybody, if it's open data, public license, and so on. It doesn't matter. You have to write it there. You have to attribute the information for people to actually have a reference to where it comes from. And this is even more important when you get data sets and when you build data sets. And that metadata that we talked at the beginning, licensing should be the first thing that you say. It doesn't matter what kind of license, if it's opened or not. People don't know, and it's important to share this information in a structured way. Just think about the fact that we get gigabytes of data every day from satellites. It is super difficult to extract information. You know, actually a problem at this point in our human race evolution is that we have so much data, then we don't really have all the tools necessary to extract the information. And at least for the European Union and with all their sentinels, their satellites, it's a problem. It's not only about storing data, it's about querying it and getting a real answer, you know. So actually, even if that's not very important, maybe you have 5 tabular data sets, and you're thinking that it's not important to write from where you got them and to who, to what purpose, but imagine that in 10 years you will probably not know. And if somehow you have to get back to that information, it's going to be really difficult for you to, I don't know, remember everything that you did and how you got that data and what kinds of correlations you did and so on. So that's something. So I think we are, for the next very few moments, I'm going to talk about mapping tools. And actually this is very simple because I was going to present to you the something that I really like and I really appreciate, which is called the OSGeoLive. I think I've mentioned to my fellows from the data school this OSGeoLive thing. But I want to share it with everyone, and I'm going to share my screen actually, and I'm going to share the link where you can find it, because this OSGeoLive is a live CD, like a bootable DVD that you can put in your computer, and it just opens a new operating system, which is a flavor of Ubuntu something. I'm not really sure which one. I think it's Ubuntu. And this is a system that has a lot of programs installed, a lot of instruments installed for GIS analysis, even if we're talking about desktop GIS, and maybe most of you have heard of QGIS. Some of you have heard of, I don't know, GraphGIS, and there are a lot of them. They're open source or free. And you have instruments for web mapping, for data storage, like spatial databases already installed there. So the actual real power of this OSGeo Live is that you don't have to install anything on your computer. You just have a bootable DVD or a bootable USB, or you can just install a virtual machine on your computer, and you have all the tools to do your data, to analyze it, to query it, to make beautiful maps, and so on. Another very important thing about this OSGeo Live is that it is very well structured and it has a lot of tutorials. The reason why I chose today to speak more about the principles of mapping and the principles of understanding the data and looking at it is because nowadays you just need a few hours, an internet connection, and a lot of interest and curiosity to do a map, because you have huge amounts of documentation everywhere. And it's really important when you start on this road to have some basic principles of what mapping is, if what in the world is a cartographic projection, and why do I care about it? I just want to put my, I don't know, my countries on some kind of a site and make them pretty, look pretty. So this is why I chose not to make this a very workshop type tutorial, but I can do so at a at a request from. So now I am sharing on the chat. I shared, I think. Yeah.
Super.
I shared.
Thanks. Thanks so much. No, and I think I really enjoy like the way you framed it, like by thinking about maps not necessarily from, you know, from a tool centric, but what's the theory behind it, so that you can make good decisions whichever tool you're doing. I think that's super important, because we have done a QGIS sharing session before, and certainly we'll do more more in-depth ones, but we've never had a 101 on like what does it mean to construct a map and what are the decisions around it. So super interesting. We've got about 5 minutes left, just so you know. Does anybody have any questions for Codrina? But I know you have some more things to share, so I want to hand it back to you, and I'll just watch for questions, okay?
Okay, perfect. So I have another slide that I'm going to share with you. It's a research slide. It's actually what I'm presenting. It's a slide with open geodata portals. So just imagine that you have, and I got the idea of the slide seeing a question on Ask School of Data. There was someone asking for some shapes of the world countries or something like that, and I thought, oh, we should have like this kind of page with sources from where you can take that data, where it's cheap. So what I did was made a really small kind of slide with that, but I think it's important, and I'm going to share it. It's number 14, and I hope everybody can see it. So what we have here is a few portals with data from where you can download free, you know, with an open license, like we talked before, and you can use it in your data, in your analysis, however you see fit. Even if you're thinking of, for example, I don't know, using a nice base map, you know, or even if you need a geometry of a place for which you want to connect your tabular data. You just imagine that you have a CSV file where you have the name of the countries and, I don't know, some kind of information related to the countries, and you just need the geometry of the countries. You are not going to start and draw the map of the world. You are just going to go on this natural earth, and you're just going to download it from there. Then you do a simple join, and there is your map, geometry and data behind. So again, this is just a very, very short list. And if we are at this subject, I'd like to draw your attention on the public data, the public open data sites, portals that are starting to arise everywhere. You know, there are those websites, if I can say so, that are called data.gov, .us, no, .uk, .pro, .al from Albany, whatever, .dk, and these are websites these are portals, official portals with open public data, open government data. That means that the data you have there is official. That means that it was collected or produced by an official body. So,
and you can also get and you can also get data from OpenStreetMap. You can download layers from OpenStreetMap too, which is community created.
Yes. Yes, community created. Actually, I think I forgot to put that here. You know, I'm so accustomed with it that I find it natural for everybody to know about it and everybody to use it. So
there we have it. OpenStreetMap. Default to that. You're welcome. Sorry, I have map politics. I think that there's lots of data sets that you can get, and I think it's really important to put the license and you know, just to be able to do the project of whatever you're doing, but just to give as many free resources as people need is important. So we have a couple more minutes, so please go ahead.
Okay, so for a couple of minutes, I'm just going to share with you my last slide, which I am very proud of. So my slide number 15, I think. Let me share it. It's this one. I hope you like it. A map is the most scientific work of art one can truly hope for. And actually, this is the first satiric comic map of Europe at 1877. Well, after this war in 1877-78, Romania became independent, so this is an important map in my with my perspective. So thank you.
When the power was cutting out, I was sharing about a map that I saw that had Russia as the bear, right? And it was before this map. And I saw, like, at the German History Museum in Berlin, I saw some other maps that had creatures on the maps. And I saw some in Venice too. I'm so fascinated by this idea of using imagery to portray geopolitical situations or points of view. I mean, not that this is actually like to scale and works on the right parameters or anything, but it certainly is a fun way to kind of look at maps and think about how they tell stories too.
And actually how these maps present the situation. Because you can see here, actually this map presents the political situation at that time. You know, you see Spain sleeping, you see Russian that is fighting with the Turkish, with the Ottoman Empire, because this is actually what's happening. This is the Russian-Ottoman war here. And you can see from this map, if you know the political situation at that time, you can actually see that this cartographer made them fight. You know, you see this Turkish guy just grabbing the octopus, the Russian octopus. So anyway, this is one of my favorites. I'm sorry if I overdid it a little bit.
No, I think it's a super interesting way to close. So Codrina, thank you so much for sharing all this information and some resources.
And for my treat, see here. I think I've lost you again. This is not possible.
The video? No, probably not. Codrina, so did you have any closing comments for today? And I just want to say thank you so much for joining us.
Well, thank you for giving me the opportunity. And now the treat that I spoke about, I'm just sending you the links. The link actually, there are 3 series of map documentaries that are super interesting. You know, you don't have to be a cartographer to watch them. And another thing that I'm going to share with you is probably something that some of you already know about it, but is the David Rumsey map collection, where you have tons of old maps that are simply beautiful. So this was the treat I was talking about, and I think at this point I am done.
Okay, I just wanted to say thanks so much for the treats. I'm totally gonna not do my job this afternoon. Just kidding, folks. No, I think that I really truly appreciate your time, and I wanted to thank you on behalf of School of Data, and thanks to all the fellows who were able to join us. Even Yoranda, who is in Indonesia, and it's super late at night for him, 10 o'clock at night. So thank you, everybody. And I just want to say, everybody have a great weekend, and thanks again. I'm just going to stop the broadcast. Thanks again.
Thank you.